one single element to form the ultimate foundation of the power spectrum, and that golden master key is literally the golden ratio, phi.
Elevating phi gives us the Fibonacci Pythagorean Kepler, or FPK sequence, and the formula is beautifully, elegantly compact. It's driven entirely by raising the golden ratio to half-integer powers. What this creates is a two-sided geometric progression. Because n ranges over all integers, this progression stretches infinitely in the positive direction with exponential growth, and infinitely in the negative direction with reciprocal decay.
And this brilliantly illustrates the sheer horsepower of Chung's framework. When we evaluate this single phi-driven sequence, we aren't just finding a handful of constants anymore. We achieve a jaw-dropping greater than 98% match rate in generating over 40 different known mathematical constants.
Let me walk you through this massive aha moment, because it's pretty overwhelming in the best way. Purely by scaling powers of phi, we get the copper ratio from phi cubed. We get the limnescape constant from phi squared. But when we scale the negative powers, it gets even crazier. To put it in perspective, 100 times phi to the negative 11.5 yields Euler's E. 1,000 times phi to the negative 12 produces Archimedes' pi. The sheer volume of famous constants born directly from phi is visually and conceptually breathtaking.
They call this elegant, unified structure the phi ladder, and it completely solves our original problem. When you climb up the positive powers of the ladder, they map out and closely mimic Fibonacci whole integer sequences. But when you climb down into the negative powers, they cascade perfectly into the famous irrational constants of our universe. It is the ultimate unification of discrete and continuous mathematics under one cohesive framework.